Hey there everyone, this is Mash here. We're going to be doing some maths, I hope, and we're going to be doing Mathematics Paper 2 of 2019. Yeah, for SQA. Let's get cracking into it. 80 marks, so it's going to be a long haul, I'm afraid. So there's your formula sheet. Make sure to go back there if you're ever in need of inspiration. Now, first question. Oh, and it looks like we've got a relatively simple straight line triangle ones. SQA like to have the easier ones first. So, yeah. And, well, let's get cracking. So triangle ABC is vertices. Vertices, fancy word for corners. A minus 5, minus 12. B 11 minus 8. C minus 3, 6. Cool. And then, well, I want us to find the equation of median BD. So let's go and write down that. Go for A. Equation BDD. So if we want to get an equation of the line, we're going to need 2 points. And well, we have one, we've got B right there, but we need D. Now if we look closely at this, D seems to be right in the middle of that, but we can confirm this because it's a median. And medians, they always go through a corner, and then the opposite side, they go through the exact midpoint, the middle. So if we calculate the midpoint of CA, then we get D, got B and D, then we can calculate the equation. Okay, let's do that. So, midpoint formula. I'm a bit old hat. I always use the midpoint. I like a formula for this. I don't know if anyone else does, but it just kind of helps me in my brain, eh? But all you're really doing is averaging out the x and y coordinates. That's why I'm adding them both together and dividing by 2 here. Okay, cool. Let's go and run this through. So that's supposed to be a 2. X1 plus x2. So we're going from C to A. It doesn't really matter. We're just adding them, so it doesn't matter which order you do them in. But for reference sake, I'll do 1 as A. So that means it'll be minus 5 plus minus 3. Because minus 5's there and minus 3's there. Comma. Then y1 plus y2. That's going to be minus 12 plus, and it goes to 6. If I actually knew how to draw straight lines, but oh well. Minus 5 plus minus 3, that's minus 8. And what's minus 8 divided by 2, you may ask? Well, it's got to be minus 4, ain't it? Minus 12 plus 6, that's going to be minus 6. So if you divide by 2, we get minus 3. And there's our coordinates for D. Fantastic. So then I'm going to calculate the gradient of B to D. Let's go and do that. Right, so let's substitute the numbers into our equation. So we'll have y2 as D this time. So that means minus 3 minus, and then we'll go to B, and its minus is minus 8. So we'll put those in brackets because otherwise these double minuses, they can really get quite confusing. Okay, so then we'll go over here. That's a minus 4. And we're going to 11. Okay, let's compute this through. So minus to minus, that's going to be a plus. So minus 3 plus 8, well, that's got to be 5, right? Because it's just 8 take away 5, essentially. And then minus 4 take away 11, well, that's effectively the same as minus 11 minus 4, which means it's going to be minus 15. Fantastic. And oh look, what do these numbers have in common? Well, they're both multiples of 5. So we can represent this whole number. 5 divided by 5 is obviously 1, and 15 divided by 5 is obviously 3. So there we go, there's our gradient of BD. Now we just need to shove it into our equation. And our equation is another one of those things you're just going to have to mind. I don't think you necessarily need this for marks, but I just remembered it's not too bad. So y and x we don't need to worry about. This will make sense later. But a and b are the coordinates of the point of the line, and that will be, in this case, it can be d or b. You can use it to check your answers, but I'm going to be using b because we've calculated d, right? So we could have made a mistake here, but just in case, we're going to be using b because it physically tells us. And m, well, that's just what we've worked out. It's a gradient. So let's go and shove these numbers in, right? So b, we figured out that that would be -3. So put that in brackets. Then minus third x, and then minus a. We figured out that'll be -4. Fantastic. Let's compute this through. So y minus -3 is the same as y plus 3. And then if we times x by -1/3, we get -3rd x. And then that can be represented as +4 effectively. So I'm going to put that as that. But it's being, yeah, so it's going to be -4/3. Now I really don't like having having all these annoying fractions, so I'm going to multiply everything by 3. And then I'm going to take away 9 from both sides, just so we can have y equals something. And -4 minus 9 is -11. Well, it would be in a parallel universe. It's -13. I don't know what happened to me there. See, even I make mistakes. But yeah, there you go. There's your answer. There's your equation of BD. And we'll continue. It wants us to find out now the equation of altitude AE. So again, they might just give you the triangle and expect you to just work this out, but they've actually drawn it in this time. And what an altitude is it goes through the corner, so it's kind of like a median, but this time it intersects with the opposing side at exactly 90 degrees. Okay, so what we're going to do here is if we calculate the gradient of this line here, CB, then that means that we can flip it using the perpendicular gradient formula and get the gradient of AE, and since we already know a point on that, A, we can calculate the whole gradient. So yeah, enough waffling, let's actually get to doing. So, let's figure out the gradient of CB. We'll actually go BC, probably. I need to start actually putting stuff in alphabetical order. Fantastic. So we'll have C is Y2, C is the second one, and B is the first one, just to make things confusing. So C, its Y coordinate is 6, and then B's Y coordinate is -8. That's over -3 and 11. Fantastic. Let's run this through. So 6 minus -8, that's essentially 6 plus 8, so that would be 14. And then 3 minus 11, that's -14. Oh, and look at this, both the same number. So we can represent this as -1. So then, perpendicular gradient form, and this is not going to be exciting in the slightest, I'm afraid. This is a really boring outcome. But yeah, this little sign here just means perpendicular. And then it has to equal -1. So if these gradients can time together and make -1, they're perpendicular. So I'm going to throw that in there. And, well, if you times a number by something and you get the same number out, what is that number going to be? It's going to be 1. In the plane, +1. So we figured out the gradient, and then we can start doing the numbers. So y minus b equals m brackets x minus a. Fantastic. So we only what point we know is a. So that'll be minus 12 equals. I'm not even going to put 1 in there because it does nothing to the equation. But yeah, fine, I'll put it in just for old time's sake. And then minus 5. Beautiful. We'll simplify this a bit further. We'll get rid of that puny 1. Sorry. And then we'll just take away 12 from both sides. So it'll be x minus 7. And there is your answer. Now, last part of question 1c. Find the coordinates of the point of intersection. Now, when I say intersection, your mind should be immediately bringing up simultaneous equations of b, d, and ae. And we've already figured out both of their equations. 3y equals minus x minus 13, and y equals x minus 7. Okay, so I'm just going to write down both of the equations. So we already have that one there. So that'll be easy just to copy. Then the other one's down here is this. Is it plus or minus? Can't remember. It's already been so long ago. No, it's minus 13. Okay, and well, since y equals x minus 7, I'm going to substitute it into this equation here. Okay. Fantastic. Let's go and multiply out these brackets. Fantastic. We're going to add x to both sides. And finally, we're going to add, well, actually finally, we're going to add 21 to both sides. That's supposed to be a 4. So add 21 to minus 13, that's, alright, my head, like 8. Okay, and then if we divide both sides by 4, we'll get 2. So x equals 2. But we're not out of the woods yet, because remember, we want the coordinates. Alright, so I'm going to take the simpler equation, this one, because I don't like doing maths. I'm going to put 2 in it. And what do you know? Y equals 5. So this then means the coordinate of point of intersection, yeah, that's supposed to be minus, sorry, is 2 minus 5. And you can do that with this equation here, but it's just more long-winded. It's easy to do it there. And there you go. So if you want to double check this, you can put this through the equation and see if it, like the second equation, just to make sure it all works. But yeah, that's all you need to do. Moving on to 2. And oh boy, that looks like a beautiful little integration question. So I'm going to go and shamelessly steal this because I'm too lazy to do anything else. But how we're going to approach this? Well, first thing what you're going to do is I'm going to look at this. I'm thinking 6 root x. That does not seem like a proper, that does not seem integratable. So I'm going to convert it into its power form, right? So we're going to have 6x to a half, because root x is the same as x to the power of a half, but everything else looks dandy to me. Beautiful. And remember your dx's. I'm sorry, I keep getting caught out with these. They're really irritating. But yeah, let's go and run this through then. So integration, remember, you add 1 and then divide to the power, and then divide by the new power. So I'll do this nice and slowly just to get, because I usually just do it all at once, but I'll do it slowly for your benefit. So adding 1 to the power here, so since it's a fraction we add the denominator on to the numerator, so we get 3 over 2, but then we're going to divide it by 3 over 2, and this will make more sense later. But hopefully these ones are a tad easier. We'll have minus 4x minus 2, and then we divide it by minus 2, and then we'll have plus 5x. Okay, so one thing we have not put in though, plus c. Okay, remember this is a indeterminate or unfinite or whatever it is. It's a unlimited integral. I forgot how the name escapes me now. So we have to put in the plus c. If there was limits on here, so if there's like 1, 2 or whatever, you wouldn't need to put in because it'd be calculated out. But since it's indeterminate, we need to put a plus c in. But let's go and calculate these weird fractional terms. Now remember, when you divide by fractions, it's the same as multiplying them, but if you flip them over. So that means we can just go like, we can times that by top number by 2 and divide by 3. And so that leaves us as 12. And 12 divided by 3 is famously 4. So 4 like that. Minus 2 divided by minus 4 divided by minus 2 is just 2. So we're actually going to flip a sign. And then we don't need to do anything with 5x. And remember your plus c. Fantastic. So that should be it. All done. Yeah. So that's an easy, however many marks? 4 marks for 4 lines of working. I consider that a decent deal. On to number 3. And this one looks like a good old-fashioned vector question. So this one, the style one, this is only a 3 marker, the whole thing, and it starts off with a nice 1 marker. So when you either see these, you can just write down the answer. You don't need to do any working. But let's have a think about this for a second. So we know we want to get from B, we want to go up to E, but we don't know what this thing is. But let's see if we can find an alternative route, because I think we can go back along P, then up R. Okay, so when we want to go backwards along a vector, we need to have a minus, right? And then we're going to go up R the way it's intended, so we're just going to add, and then we're just going to set it equal to BE. And there you go. That's it. Just a mark, eh? B is going to be slightly harder, because there's a grand total of 2 marks, and we're going to have to do some funny ratio stuff. Because it says point F divides BC in the ratio 3:1. So I always misunderstood this, but basically what this means is that the longer distance here is 3 bits, and the shorter distance here is 1 bit. So 4 bits in total. This will help us later. But first thing we want to do is we want to get a decent-ish pathway. So it's vector E to F. So maybe we could go E to B and then B to F. Because then E to B, if you notice, that's just the reverse of PT. So that'll help. So I'm just going to say E to B plus B to F equals E to F. Cool. And then we already know what E to B, that's going downwards along R, and across P. So yeah, the reverse of that one. Now B to F, it would just be Q, because if it was B to C, because remember Q, this is all at these are all at 90-degree angles here. So you can shift Q along there, and it would be the same as B to C. But it's B to F, which is slightly shorter. So remember I said it's 3 bits to get to F and then 1 bit, and it's 4 in total. Well, doesn't that make you think of fractions? So if Q is going all the way over to C, then 4Q, but if you go all 4 bits, that would be go to C. But if you only go 3, you'd go to F. So you'd be going to 3 over 4q. And then we'll just make sure you equal it to EF at the end. And there you go. Right, well, we're zipping through these now, and we're on to 4. This one I actually probably going to have to pull up the calculator. In a forest, the population of a species of mouse has fallen by 2.7% each year. To increase the population, scientists plan to release 30 mice into the forest at the end of March each year. U is the estimated population of mice at the start of April, n years after the population first estimated. It was known that these satisfy this relation, state the value of A and B. Okay, well this is one marker, so we can just write down the answer. So A is the multiplier, and I think this is going to be something related to the percentage. So if it's falling by 2.7% each year, that means that if nothing happened, if it increased by 0%, so it's falling, it's going to be reducing itself by 2.7%. And remember, we need to convert this into decimal, right? So we go 0.027, and what does that get as well? It gives us 0.9 73. Right? Cool. So that's going to be A, and that's it. That's literally it. That's all you need to do for A. For B, well, they release 30 mice into the forest at the end of March each year. So see here that each time you go around, you add 30 mice. So B has to be 30. Ain't that fantastic? Now, you can also just write this in the plain recurrence relation, but you don't need to. You just need to state values of A and B. So why bother doing any more work than you have to, eh? We'll move on to B now. And it's going to be split up into I and 2I. The scientists continue to release the species of mice each year. Explain why the estimated population of mice will stabilize in the long term. So when you have a recurrence relation, if the A term, this here, is between -1 and 1, then there will be a limit where even if you go infinitely far in the future, it will just stay the same. It won't move. So way you do this is let's just say a limit exists, if I can spell, I can't really spell, as the recurrence relation is linear. Now what linear means is that this stuff over here, it has no powers, it's just multiplying them, like it's like a straight line, you know, there's no weird powers, it's just multiplying them by different coefficients. And -1 is smaller than, that's not 973, 1. If it's greater than 1, then it will just fly off into infinity. If it's -1, it'll fly into negative infinity. So you can just kind of copy and paste this in. Now, only detail to note is that 0.973, you need to work that out correctly and put it in there. If you're doing this for a different question, you have to work out their own thing. But that shouldn't be too hard. I believe in you. So probably should up the resolution now that I think about it, but here we are. So calculate the long-term population to the nearest 100. So I'm just going to be lazy. I'm going to be using the formula if I can remember it. It's just B over 1 minus A. Okay, so this is the limit formula. Now B, we've already worked out, is 30. And 1 minus 0.973. And then we can just, I'll go and pull up my calculator and work it out. So 1 minus 0.973, that's 0.27. So if we see that, we got 30 divided by 0.027. Notice it's the same as the percentage we originally got. We'll get 1,111. Okay, so we can write that now. And 0.111 to infinity. But notice, that it says on here to the nearest 100. So we've got to actually round this. So I'm going to round it down because it's not over 1,150. So it's 100, 100. I'm going to put mice. You don't need to have the add the mice in there, but it probably helps just tie your answer back. All right, moving on to 5. The diagram shows the graph of a cubic function with stationary points x minus 2 and x equals 4. On the diagram in the x against the graph of the derivative of this function. Righty. So I'm going to go and make a beautiful wee graph here. Right, after I've finished drawing a graph that took a wee longer than intended. So there's only 2 marks, so we don't need to worry too much. But we're going to have a look at this, right? Stationary points. Now remember, SPs occur when gx, well, the derivative of gx equals 0, right? So that means that it's got to cross the x-axis at the stationary points, right? So that means we can just throw this in here. So we can go, okay, well that's going to be minus 2, and that's going to be 4. So that's a good start. Now, next we're going to have to look up here. Now remember, derivative is positive above the x-axis when this is going up. When it's decreasing, then it's below the x-axis. So I'm going to have a draw here. I'm just going to draw plus signs. And then, oh, it's starting to go negative. And then, oh, it's going back up, right? So that means in between minus 2 and minus 4, it's got to be below the x-axis. But everywhere else is going up. Which means it's our old favourite shape, the parabola. And yeah, you can do it pretty rough, as you can tell. My artist sheet's not good, but it's roughly looking like this. Now, this is the equation. So what I don't in the diagram looking at it here. I don't think you have to do it. You just have to be passable. But if we average out these numbers here, so minus 2 plus 4, that would be 2 and divided by 2. So that means that the middle of this thing here will be at x equals 1, which means probably best to mark it on your graph. You won't need to work out the gradient because it won't tell you, but you can put maybe a dotted line if I can find where that is. No, I can't. You can put a dotted line here that says, okay, it's at x equals minus 1. But if I'm reading this correctly, I don't think that's particularly necessary, so I wouldn't worry about it. But I'll draw it in just to make sure you guys know what it's up. Anyway, moving on to 6. And this is where things get dicey. Express 2 cos x minus 3 sin x in the form k cos x plus a, where k equals yada yada. So, this is an interesting question. I'm going to go and start by writing 2 cos x minus 3 sin x equals k cos x. Well, you might be wondering, how on earth are we going to do this? Well, when I told you about the formula sheet, let's scroll up there and see if there's anything we can find anything that might be useful. And oh, look at that. This looks fairly useful, doesn't it? So, what we're going to do is we're going to substitute this into this, right? Okay, so 2 cos x, this all remains the same. We're not doing anything weird here yet. But if we throw this out, right, so I'll start slow. So it's essentially k times cos whatever this is going to be, which is, so cos x, so we start with cos x because it's cos a, right? And then it's cos a because we do the second. And then notice how this sign is flipped over from that. That means you take the opposite of this sign. So it'd be minus instead of plus. And then we do sine. Sine x, sine A. Then we're going to multiply that out equals K. Yeah, it's very important you write this bit. You can skip the above steps. This is just for illustrative purposes. It's very important that you write this pretty much perfectly, because they have it. You have to have those stated explicitly. Sorry, I'm not able to talk today. For example, I just made a mistake. You need to have K, because remember, we're timesing a bracket. We have to times everything, all the stuff in the bracket, by K. Fantastic. So, what do you notice about this? Well, I noticed that K cos A, that's got to equal 2, right? If these two equal each other, the thing that multiplies cos X is 2. So that means K cos A must equal 2. That's not how you write stuff. Cool. And similar thing to here. Minus 3 must equal minus K sine A. Now, I'm going to divide both of these by 1. So that means, because you want to end up with just K sine A equals something. Equals 3. Okay. So then, okay, we're working out that pretty well. And then we just need to go and calculate out K. So K is unfortunately pretty boring. All we're going to do is K equals root, and then it's these two numbers squared. Right, so that's 4 plus 9, so it's root 13. Fantastic. Alrighty. So, how are we going to do this from now? Well, we'll use the K later, he'll come back later. What we can do is, remember, when you divide sine by cos, you get it's the same as tan, right? So I can go K sine A E over K cos A equals tan A, which means 3 over 2 equals tan A. And before we do that, I'm going to just quickly do a this is a CAS diagram. I always remember it as all smokers take cancer, we dark, but here we are. And we're going to look at this. Well, sine A is positive, so it's either in first or second, and cos A is also positive, so it's either in fourth or first, which means it has to be in the first quadrant. So we can actually be quite lazy here and just say A equals inverse tan of 3 over 2. And we're going to have to pull out our calculator with this, so where is he? Oh, yeah, I need to put them in. So 3 divided by 2, 1 over 5, and then inverse tan, 56.31, so on and so forth. So then, well, all we need to do here is we'll scroll back down to what we're working on, and we need to express it in this form. So that means we can just combine everything together. We know K is root 13, so root 13 cos X plus 56.31. And I put the degree sign on there. So yeah, there you go. And then, well, we've got another part to this question, unfortunately. So if we move down to B, hence solve minus 2 cos X minus 3 sin X equals 3, and this interval. So what we're going to do here is I'm going to go and, well, shamelessly steal it, obviously. Right, but then we've already figured out that this here equals this, so we can just go and slot that in. Alright, so then what we're going to do is divide both sides by root 13. Fantastic. Okay, then we're going to have to do another cast diagram. I know. Oh, smokers take cancer. And cos is positive in the first and fourth quadrant. So we're going to get answers there. Well, since it's in the first quadrant, we can actually be lazy and just take inverse cos of that and get a first answer. So yeah, I'm going to write down a wee table. So we have first quadrant, and then over here we have fourth quadrant. So x plus 56.31, and then in quadrant 1 it will be, draw a line here, cos, no, I need to do an equal sign, sorry, it will be cos, inverse cos of 3 over 13, root 13 I should say. But then in quadrant 4 it would be 360 minus inverse cos. Because remember, when we look at this diagram, we only measure from the horizontal line. So if we wanted to get an answer in the fourth quadrant, we need to take away from 360. So it would, because 360 is here, and it goes around counterclockwise. So, if we want to get an answer in C, we have to take away from 360. Okay. So what is inverse cos of 3 over half? Right, I'm back. I'm just really not the brightest in the room. So there we go. There's our answer. 0.83. So I'm going to write that down. Alrighty, so we've got this, and then I just need to go and inverse cos it, and we'll get 33.69. So yeah, we'll just do 2 decimal places. It doesn't particularly matter. So our first answer will be this. Well, almost answer. Remember, we've got this phase angle to worry about. 360 minus 33.69. Cool. So I'll go and process this. So that will just remain as 33.69. But then we need to take away that from 360. So $26.1. Fantastic. Okay, now the interesting bit though. We've got this phase angle to worry about, which means that we need to take away 56.31 from both these answers. So 33.69 minus 56.31. Uh-oh, we've got a negative answer. Don't worry about it, we can sort it out later. And then this one should be no problem. 26.1. No, it's 3.1, isn't it? Sorry. I'll fix that. Minus 56.31. We get 270, which is a nice, good number. So how are we going to fix this minus? Because remember, we've got to have it in this interval here. It has to be higher than 0. Well, when you're in a situation like this, you can just add on the period. Add on the period will give you the same solution, just a couple degrees, like it repeats, right? And this is a regular cos graph. There's no phase angle coefficients, So the period is just going to be 360 degrees. So we add 360 degrees onto minus 22.6. Get that out here. 360, 7.38. And we're just going to round it to 0.4, 270. And there you are. Those are your two solutions. But yeah, maybe it's, I've just realised it's probably best to leave it as 2 decimal places. It's a good middle ground. Anyway, so there's your solution. X equals these two. And we're on to 7. We're blasting through this, as you can see. Express minus 6x squared plus 24x minus 25 in the form p brackets x plus q squared plus r. Okay, so this is a this is basically extracting the square, putting it in the square form. So how are we going to do this? Well, first things first, I'm going to write down the formula, and by that I mean shamelessly steal it from here because I got a computer. Okay, so I do this in a bit of a weird way, but it works, so who cares? We just remember when we're doing this, we just care about, we're going to start by dividing minus 6 and 24 by minus 6, okay? So this will make sense soon. Right? So we have x squared, and then it'll be minus 4, because we divided it, and then minus 25. So yeah, this is still the same equation, but we've just split it up a bit. Then what we're going to do is we're going to turn this into a square term, and that means we have to go minus 2, because when you do this, you take away the power from that and you divide that by 2 and get squared. Now, what we need to do here is we need to take away this power. So if we go minus 2 squared, that's 4. So you think you need to take away 4, but remember, we're actually timesing it by 2. By 6, minus 6 I mean. So instead of taking away 4, you'd actually need to add on 24, because this minus 6 reverses just a sign. Then all we need to do from here is just clean things up. (24) minus 25 is just minus 1. There we go. Okay, and that's all we need to do for A. That was 3 marks right there and there. So for B, how are we going to do this? Well, it says, given that fx equals this number, show that fx is strictly decreasing for all x of real numbers. Okay, well, whenever we get something like this, and we want to find out if it's strictly decreasing or whatever, I always think derivatives. Okay? So I'm going to go, I'm looking at this right now. I don't think we need to do anything to prepare it for differentiation. So I'm just going to go straight into it. Of f, so we take away 1 from the power, and we times it by the power, then take away 1 from the power. So we have minus 6 x squared plus 24x, take away 1, so it should be x. And then it will just be minus 25. And then 9 disappears because it's a constant. And doesn't that look familiar? It's the same thing. Which means we can substitute it in, and we can say that the derivative of fx equals minus 6 x minus 2 over 2 minus 1. And well, I mean, you don't need to do this. There's actually several reasons you can figure this one out. But essentially, we need to show that this equation here will never go above 1, or it will never go above 1 or 0, right? Because if it goes above 1, 0, since it's a derivative, that means that this would be increasing. But it has to be strictly decreasing. This number has to always equal, be below 0. Draw a graph. Yeah, oh, sorry for that cut, I'm just a bit lazy. So yeah, let's get cracking. So what we can figure out from this is the turning point would be 2 minus 1. But because it's a minus 6 term, it'll be a negative parabola. It'll be, we call it the upside down face in the business. So that means if I draw my graph here, it roughly be like this, all right? And then this point here would be 2 minus 1. I'll put that in orange. So then we can say that the maximum value of derivative of f is minus 1. So that means that minus 1 is lower than 0 for, and this symbol here means all x. Yeah, 0, so that means, this means that, sorry, I should have said that, is lower than 0. Then I'm going to have a with symbol here. So this means for all x. So you can put any x in here and this will always be true. So then we just need to conclude, we need to tie it back, so we can say it's always strictly decreasing. Yeah, but so this does look complicated, but remember you just need to explain the maximum of this is below the x-axis, so it'll never be above 0, and since it's never above 0, it'll always be strictly decreasing. That's basically what this word soup is saying. Okay, another page. A function f is given by fx equals cube root of x plus 8. Domain is yada yada, the inverse function exists. Well, that's helpful. So, we need to find the inverse function of f. The way I do this is I'm going to start by shamelessly stealing the function. Fine, here we go. And then I'm going to say let y equal fx. So this will mean y equals cube root x plus 8. Then we can rearrange this for x. So that means y minus 8 equals cube root x, and we're going to cube everything. So that means y minus 8 is 3x. Okay, so then we've got it rearranged, and then we just need to state that f minus 1 x equals x. Remember to put x here, not y. 3. And there we go. So yeah, it's not too many marks. Oh, there is 3 marks, so that's fine. So then we need to figure out the domain of this new inverse function we've created. So the domain is stuff that you can feed into it. It's the values that you can throw into the function. Okay? So, well, we already know the domain of the original function, right? And this new function here essentially undoes the work of the original function. So that means if I'll draw some lines. Oh wow, yeah, I love premium features like being able to switch to the yellow color. Wowzers, guys. We have 2 lines here. The original function, you know, takes us to there, and then the inverse function takes us back. This means, this seems pretty obvious, but what this allows us to do is figure out the domain of things. You only go to undo things that have gone through the original function. So if you put the domain limits into the original function, so that would be 1 over root 3 plus 8, and then 1000 plus 8, into this? Well, cube root of 1, that's still 1, so that'll be 9, because it's just 1 plus 8. Cube root of 1,000, that's got to be 10, so it'll be 10 plus 8, so it'll be 9 and 18, which means that the domain would be like this. There you go. And if you want to be really fancy, you can actually go and say x is part of all real numbers, but you don't need to do that. That's just if you want to impress your friends. 9a. Electricity on a spacecraft can be produced by a type of nuclear generator. The electrical power produced by this generator can be modelled by this exponential equation, where P is the electrical power produced in watts after T years. Determine the electrical power initially produced by the generator. And, well, it's a term, it says the term, and it's only 1 mark, so we can actually be really lazy and just say P equals 120 watts. Now, how did I figure that out? Well, if you look in here, initially, right, that means as soon as you go off, which means 0 years, right? So if you times that by 0, it makes whatever that is into 0, and then you have anything to the power of 0, right? Well, that's just going to equal 1. Okay, that's just a standard rule, which means it's 120 times 1, so it's 120. And that's A done. Another free mark for us. Don't mind if I do. So next up, it's calculate how long it takes for the electrical power produced by the generator to reduce by 15%. Okay, so what we're going to do is figure out what's 50% less of 120. So 1 minus 0.15. So that means that it'd be 85% of the original generator. So if we times 0.85 by 120, we should get, I think it's 102, but I'll just go and double check on the old calculator. Remember, in a calculator paper, there's no shame in using your calculator. Use it as much as you can. There you go, I was right, it was 102. I even wrote it down by accident. 102. So then we can plug this into our equation. So that means we get 102 equals 120e to the power of whatever that nonsense is. Yeah, I'm really sorry about my handwriting. I say this in every video, but I'm just something I really should work on. Okay, right, let's go and start solving this. So if we're going to divide both sides by 120, we have 102 over 120, and we'll sort that fraction out later. And yeah, in fact, we'll sort it out as soon as I finish writing that down. Make things easier. So 102 divided by 120. We can go and, well, we already know what happens when we divide it. Remember, because if we times it by 0.85 to get 102. So if we divide it by 120, we're essentially undoing this. We'll get 0.85 right back. Ain't that a miracle? Okay, and this stupid e term is in here. So I'm going to take log e of both sides, log base e, and that will get rid of e. There's t on here that I've been forgetting. Okay, so if we can, on this side, these two cancel out. So it'll be log e of 0.85 equals minus 0.0079t. And then we just need to divide, oops, we just need to divide both sides by minus 0.0079, and then we'll get t. So we're with this monstrous formula that I'm going to have to go and show with work in the Windows calculator. But yeah, you can see my struggles. So we already know it's base 5. So we can put 0.85, and then where's the second function of, oh, here we go. So in, that is natural log, so that's what we want. So minus this horrific number. So that's the top line done, and then we just need to divide it by, so it'd be 0.0079, flip it so it's like that, accidentally boot up around the program, I don't care about, and we'll see what we get is 20.57 years. So I'll just conclude, say 20.57 years. Perfect. Okay, moving on. Ooh, we're on to 10. So yeah, we're actually getting close, guys. Well, close, I mean, it's like halfway there. 10. Show that. That's a gift. That means it tells us the answer. But we need to show that x plus 3 is a factor of this horrific thing. So if x plus 3 is a factor, then that means that x minus 3, well, actually just minus 3 is a root. And that means we can use synthetic division, ain't it called, to figure this one out. So we put the coefficients of this thing in here. So we have 3, 10, 1, minus 8, minus 6. And I'm going to put minus 3 in there. Let's see what happens. So 3 just gets carried in there. We times minus 3 by 3, we get minus 9. So that's 1, minus 3, so that'll be minus 2, so minus 6, so minus 2. So that would just be 6, that would be minus 2, that would be positive 6. And when you add 6 onto minus 6, you get 0. That's all you need to do. We want to B, and it's a horrific 5 mark. Oh dear. So enter our price, factorize this fully. So we know from this thing that we can actually go and represent this. I'll go and steal this from here actually, just to make things clear. But we can represent this as, we can divide this by its factor x plus 3, right? Because we figured out that that is a factor of it. And then from the numbers down here, we can work out what the other term is. So we can go, okay, well, 3x, this would be cubed minus x squared minus 2x minus 2. Okay, well now we just need to break this other one down a bit further. So we're going to do the same thing, but unfortunately we're going to just have to guess for this next one. So throw the numbers in, same numbers from here. And what we'll do is we want to find factors of minus 2 and just kind of throw them in and hope for the best. Unfortunately, so it's just how it goes sometimes, I'm afraid. So I'm we'll go and start with positive 1. It's always a good shout, eh? So 3, and it just doesn't change. So it'd be 3, that'd be 4. 4 goes in there, so it'll be minus 2. So minus 2, and oh well, minus 2 plus minus 2 is minus 4. So, well, it would be if I did my maths correctly. As you can clearly see, minus 2 plus 4 equals 2. So you'd get 2 in there, and you get 0. Sorry about that. I can be quite silly sometimes. So yeah, 1 is a factor. So if one's a root, sorry, if 1 is a root, then that means that x minus 1 is a factor. And so yeah, we can continue to do this. So yeah, x plus 3, x minus 1, and then this thing here, and it just looks like a simple quadratic. So surely factorising this couldn't be that difficult. Well, you can try as you might, you will not be able to factorise this without getting into imaginary numbers, which you probably won't know how to do because it's higher. You don't need to do it. So what we need to do here is run it through. We can check if we can actually do it or not by using the discriminant. The discriminant is the thing in the quadratic formula, but essentially this tells us how many roots there are in our equation. So I'm going to put 4 in there. Minus 4, a is 3, brackets 3, and then c is 2. So that's 64. Wow, I mean 64. 16, sorry guys. Minus 12 times 2, so it'll be 24. Equals minus 8. Uh-oh. That means that there's no real factors. So we actually cannot factorize this whatsoever. So then we can just say, since minus 8 is below 0, equation is quadratic, I guess you could say. Quadratic has no real factors, I guess you could say. You can just say you can get away with no real, but technically it does have imaginary factors. That has to be on the scope of my brain. There's no real factors. Leading. Oh, gotta love the scroll mechanic. And then we'll just write down what we have here. So I'll shamelessly copy it again. I'll see if we can get that a bit better. There we go. Boom. And there we are. Another one bites dust. 11. It's about cardboard boxes, because why not? So manufacturer of chocolates using obviously novelty say cardboard boxes. For some reason they're like, let's make a donut shaped one. Who knows why? But oh well, SQA has some wacky problems sometimes. So the total surface area of the box is given by this equation. And I'll be honest with you, this is the most painful 3 marks you're going to have to go through. So let's go and start by writing an equation for the surface area of a box, right? So I'm going to have a look at all these different faces. So first things first, face on the top, this like donut thing up here. We can calculate that as 3x squared, but we're moving this face here of x squared. So, but there's also 2 of them on top and bottom. So it leads to this. So 2 of them because the top and bottom. So 3x in brackets again because it's that times that. It's not 3x squared. It's brackets 3x squared. Then minus x squared because we're taking away that box in the center. Okay, and then we have to do the other ones. So let's do the ones around the side next, the outside side. So they've got length 3x and then height h. So there'll be, since there's 4 of them, that'll be 4 3x h. I guess I'll put it in brackets. We'll multiply them out later. And then what we need to do now is these inner ones, which have length x and height h. And again, there's 4 of them. Oh, yep. And it just gets worse from here, guys. I'm sorry. So 3x squared, that's 9x squared. Plus 4, 3x squared, so that would be 12x h plus 4xh. And then we can combine these. So 9 minus, so this is essentially 9 minus 1, that's 8, and 8 times 2, that's 16x squared, right? And then if we add these two together, they've got the same coefficients, well, no, yeah, but the same like terms. So it'll be xh from both of them, which means it's 16xh. Whew, and we're not even done yet, I'm sorry. Look at this, we've got the start of the equation, but then we need to get 4,000x. How did we get that? Well, the volume of the box is 2,000 cubic centimeters, right? So that means we get to write another equation. So 2000 equals, so how I'm going to calculate this? Well, it's essentially, so it's a box, so we can just times the this together. So that's the area of the top bit, and then times by h. But then we got to get rid of the center, this one in the center, which is x squared h. Again, this is 9x squared h minus x squared h. And that means 2000 equals 8x squared h. Ooh. And we want to move this around just to get h. So if we divide 2000 by 8 squared, get this fraction, which I'm running out of canvas room here. I'll just start moving around. Which then means we can simplify this. So if we divide this by 2, yeah, so I'm out of it. If we divide everything by 8, we'll get 250 over x squared equals h. And then we go back into our original formula. We're going to substitute it in. So this is the a equals squared x plus 16x. If you're not following on, that's perfectly okay. This is really, this, by the way, this is all for 3 marks. It's actually ridiculous, right? And well, we look at this. We can write down our final equation. 16 x times x squared, but since it's dividing, so those two actually cancel out. So we're just left with x on the bottom line. 16 times 250 is 4,000, because 250 is essentially a quarter of something times 100, right? Times 1,000, right? So you divide that by 4, you'd get 4, and then times by 1,000, you get 400. And look at that. It's the perfect equation. It's beautiful. Absolutely beautiful. Oh, and that was 3 marks, ladies and folks. Everyone else. It's, sorry. This, it's a nonsense. I'll stop dilly-dallying. We'll move on to good old B. B's a bit easier, I feel. And I'll just have to keep moving sideways so I've run out of space. So, B. Minimise the cost of production. The surface area of the box should be as small as possible. So, again, this should immediately prick up your minds when it says as small as possible. Maximums and minimums occur at stationary points. So, I'm going to write down our fancy new equation we've just made. And we're going to convert this into a slightly easier form to differentiate. So we essentially just bring the 4,000 down. And then we're going to differentiate it. So I guess it would be, yeah, it would be dA over dx. So 2 times 16, that's 32, x, and then it'll be minus 4,000 x minus 2. And then if we can say 4 SPs dA over dx equals 0. So that means 0 equals 32x minus 4,000 x to the minus 2. I'm going to add this onto the other side. So we have 4,000 x to the minus 2 equals 32x. Bravo. So then, note here, we can pull out, I can already see a solution here, right? Because if we have 0 as both of these, x could equal 0 and this would be satisfied. So x equals 0, we'll put that in the back pocket. We'll figure out why that's rubbish later, but for now we'll keep going. So x can equal 0, but I'm going to divide everything by 32, which is, oh well, let's pull out the old calculator here. My brain's fried after this whole nonsense. But I know 4,000 does get to 32 one way or the other. 125 2 equals x. And then, almost there, almost there. I'm then going to divide something. Okay, right, well, I'm going to divide everything by x to the minus 2, right? So 125 equals x over x to the minus 2, so I need a wee break there. And that, since we're dividing by negative, we're going to add on, so it'd be 125 equals x to the 3. So yeah, there we go. That means that x can also equal 5. Oh. Now, why can't it equal 0? Well, simple as that. We're doing cardboard boxes here. If you had a thing of 0, then you wouldn't have a hole, and there'll be no point to things. So you can say that as a unrealistic. Or, disregard because it's not fitting to the question. We don't want that. But x equals 5. Right. So we figured out that, but we need to figure out if it's actually a minimum or not. So we're going to do a nature table here. So I'm going to have 4, 5, 6. So that's x. And then dA over dx, and then shape. And this is where we pull out the old calc. So this this formula allows us to calculate it. So 32 times, we'll just double check with 5, minus 4,000 times 5 to the negative 2. Oh, okay, hang on, I messed that up. 32 times 5 minus 4,000. I'm losing my will to live here. Times 5 to 2, but it's minus 2. 0. Right? So we can see here that this formula says that 5 is a stationary point. So we can put a 0 there. Now just to make sure that I'm not going insane. But we're going to go 32 times 4 minus 4,000 times 4 to the power 222. So that's going down. Right. And then finally we do it for 6. So 32 times 6 minus 4,000 times 6 to the power of 2, then minus. Oh, and it's 80 or something. So that means shape looks like this. Okay, so that means we want it to be as small as possible, so we can say minimum turning. We can say it's a minimum stationary point. Boom, fantastic. Right. Now that we know what x equals 5 is, we need to work out what the surface area of x equals 5. So A equals 16, 5 squared plus 4,000 over 5. So we can just shove this into our calculator, can't we? 16 times 5 squared plus 4,000 divided by 5. Well, we get 1,200. And then cubic, it'd be cubic, squared centimeters, sorry, talk about area, is our minimum value. Oh, I'm sorry. Maybe you want to take a break now. We have been for an awful lot. This is all we've covered. so far. So yeah, feel free. I need a break especially. But right, well, let's keep going. 12. Two variables x and y connected by the equation x equal y equals abx. Graph of log 4y against x is as shown. So this is a log axis question. So what we can do here is figure out the straight line formula, and then we can put logs in it. So this one is actually quite simple. We can just go and calculate the gradients, I suppose. Yeah, I'll shut up and just start drawing. Equals m. So then y2 is 8 minus 1, and then that's 3 minus 0. So that would be 9 over 3 equals m. So 3 equals m. And look at this, we already know the y-intercept is. It's minus 1. So therefore, y equals 3x minus 1. But it's a log axis, so that means it's actually log base 4y. That equals 3x minus 1. Okay, so that means we're going to have to do some good old-fashioned rearranging. Alright, so we're going to remove logs from the side, and we're going to have everything thrown up. I mean, so essentially it looks like that. So it's y equals 4 to the power of 3x minus 1. Now we can actually split this off, right? We can just keep it as 3x and then times it by 4 minus 1. That's cool. 4 minus 1 is just a quarter. Times by a quarter. But then getting rid of these two is going to be a tad more difficult. Well, remember when two coefficiently, remember if I have x to the squared and then I have a power of 3, you can actually write that as 2, 3, i.e. x to the 6. So you can multiply them if you have powers of each other, which means that we have 4, 3 to the power of x times, it's supposed to be a quarter, that will still be fine. And what was 4 to the power of 3, I could probably remember, it's 64, but I'll just prove it to you. Yep, so 64 to x times 1 over 4. There we go. And yeah, that's actually all we need to do for that one. We just need to make sure we state what A and B are, because you can't remember, you can't times one. It's tempting because they're both they would fit quite nicely, but you can't times them because this one's got a power or not. So if y equals that means that A must equal 1/4 and B must equal 64, because we're just looking at here and comparing it to that. And there you go. So that's another 5 marks out the way. Whoa. Right, 13. For a function defined on a set of real numbers R, it's known that the rate of change of f of respect to x is given by this number. So, in real world terms, this basically means that this is the derivative of x. Okay? And the graph of equation that gets across the line at 7, 0. So this basically means when x is 7, this function will, the original f function will give out a thing of 0. You can think of it as y, right? How are we going to do this? Well, remember, differentiating is the opposite of integrating. So if we integrate this derivative, we can get back to the original function. So I'm just going to say that fx equals is indeterminate or undefined or whatever. I've looked that up. X squared minus 16x plus 11. And remember, dx, they'll lynch you if you don't write that in. Well, I mean, maybe you lose a mark, but still, always write the dx. Okay, and yeah, let's get going. So differentiate that, we add 1 to the power and divide it. So 3 divided by 3, that's 1, so we get rid of it. Minus 16x, we move that up to 2. And then minus 16 divided by 2 is minus 8. And then that's 11, so it would just be plus 11x. And then plus c, because we need plus c, because it's indeterminate. But because we know this, right? Because we know it's 0 when x is 7, then that means we can plug this in. So we can say, well, 0 equals 7 minus x, 8 to the power of that, plus 11, 7, plus c, and then we can work all of that out. So 7 minus 8 times 7 to the power of 2 plus 11 times 7. Boom. So this basically means that 28 plus c equals 0. That means that c must equal 28, which means fx equals 7 cubed minus 8 bracket 7. Sorry, I messed it up. It's just x, it's not 7. 7's filling my mind, mate. Minus 8 squared plus 11x minus 28. Oh. 14. The vectors u and v are just the magnitude of u is 4, magnitude of v is 5, and the dot product of this is 21. Determine the size of the angles between vectors u and v. So what we need to do here is figure out, we get a specific equation that we'll use, but firstly let's go and figure out what the dot product of u v is, because we'll need that for this, because if we scroll all the way up to over here, right, this is what we want to use. Angle between A and B, that looks useful to me. So but for this we need to figure out what A dot B is, which would be u dot v in this case. But then we have the magnitudes here because they tell us, and then we can just work out what theta is, the angle. So yeah, this is the second last question, folks, so don't worry, it will be over soon. So u dot u, make that a bigger dot, plus v equals 21. That means that u dot u plus u dot v equals 21. Now when you dot a dot, that essentially means you get the square of the magnitudes. In this case, it'd be 4 squared equals 21, and that's because remember the dot product is when you have two vectors, you'd go and multiply them out. So if I've got 3, 3, 2 vector, if I'm dotting with itself, then it would be 3 times 3, because it's going to I'll write this down just to further explain why this is the case. 3 times 3, that's 9, and then we're going to add that to 9, and then we're going to add that to 4. So that'll be 18, that'll be 22. Okay, and then if we work out these are the derivative, the magnitude, that'll be, well, you notice that, yeah, you're doing basically the same thing, and then you square it, square root it, right? Anyway, silly explanation aside, this is what's happening. So that means that 16 plus u dot v equals 21. If we take away 16 from both sides, we end up with the dot product being 5. Then we can throw in this equation, which is just a rearranged one of the one you saw earlier. Equals cos theta. Throw in our numbers. So that's 4 times 5. So it'll be 5 over 20 Divide both sides by 5, we get 1 over 4. And then we can just use inverse cos. So there we go. Pull out our old calculator. 1 divided by 4. Trigonometry, second function. There we go. 75.52 something or other degrees. And you can do this in radians as well. That won't punish you. But we'll just stick with degrees here. Oh, and look at that, guys. And everyone else. We're at the final question. Oh my lord. It's been waiting far. I've been waiting far too long for this. So, circle is the centre there, and the point lies on the circle shown. So it's on a tangent on the edge. And we need to find the equation at the tangent of P. So we're looking for the equation at this line. So we can do this out. If I'm going to zoom in on here, I'm going to draw a line. Remember, the line from the edge of the circle to the centre is exactly perpendicular to the tangent line, which means if we go, I'm going to delete that so you can't see it. If I go MPC, if I work out the gradient to this, I can then flip it around to be perpendicular and figure out the gradient for the tangent. So 13, then 12, so that'd be 5 minus 8. So we have 1 over minus 3. That makes sense because if you think about it, that line's going slowly down. And then we draw that a bit closer. Minus 1. So 3 times this number here. Minus 1. So the way we do that is we're going to flip a sign, so it'll be positive, and then we're going to flip over, so the numerator will be, the denominator will be in top, it'll be, and the numerator will be on the bottom, which means the perpendicular one is 3. That makes sense. It's a pretty steep incline. So if the gradient's 3 and we know a coordinate on it, we can just get cracking with the equation. There we go. Y minus 13 equals 3x minus 5. So y equals minus 13, equals 3x minus 15. We're going to add 13 to both sides. And there you go. Equation done and dusted. Okay, we're on to last couple ones here. And one of them's a 1 marker. Whoa, that's really helped. That's really cheered me up. Oh, excuse me. So, state the coordinates of t. It says tangent of p makes the y-axis of t. So we just need to figure out what t is. And, well, it's state. So I'm just going to write down the coordinates. So remember, when it's at the y-axis, the x1 will always be 0. You can just fire x equals 0 in there. But you'll find it'll be minus 2, right? Because it's, remember, c equals minus 2 in this equation, right? And then find the equation of the circle that passes through the points C, P, and T. So this one, it has tricked me quite a few times now, I'm embarrassed to admit. But essentially what we're going to do, to think about this, is we're going to join all these up as a triangle. And you're going to notice that, remember, this one here is 90 degrees. So, whenever you have a 90-degree triangle, that means that this side has to be the longest, which means that if we're going to do a circle that surrounds all this, really badly drawn, that's a bit better, this will have to be the diameter. So if you find the midpoint of T and C, T and C, that means we'll find the center, and then we can just figure out the radius from there, and then use that in our equation. So let's go and do that, hey? So I'm going to go midpoint equals x1 plus x2. Fantastic. Excuse me. So x to 0 for t, and then it'd be 8. That's not how you draw 8, that's how you draw 8. And then it would be minus 2 plus 12 over 2. Sorting that all out. I'm pretty sure you can figure out how to do that, because yeah, 8 minus divided by 2, that's obviously 4, and then 10 divided by 2, that's 5. So there we go. This point here we figured out is 4, 5. So now we just need to work out the radius. So the distance between t and the centre. That's distance formula is another thing you're gonna have to remember. Again, it seems complicated, but really remember it's just a change in x coordinate squared plus the change in y coordinate squared, and then rooted. Okay. So throw our numbers in there. Perfect. So then 4 squared is 16. 7 squared. So that'll be 49. Right, like my previous self. So we add those together. That's root 65. Right? Not root 80. Why would anyone think root 80? That means we can use... So if we go up to our formula sheet here, we can use this circle formula. We know the centre, so that would be x minus 4 squared plus y minus, that's supposed to be a y, squared equals, we're just going to square this. So square root 65 squared is just 65. And there we go.